Welcome back, dear all, for the second numerical question on the belt drive. One question we had solved on the open belt drive. The second question is on the cross belt drive. I am using the same data on the question which is given in the question number 1 for the solution of question number 2, so that we can easily compare what are the differences in the solution of a question on the open belt drive and cross belt drive. So we have to first read the question carefully, and we need to drive what is the given data. So shaft is rotating at 90 rpm and it is driving other shaft at 225 rpm. So n1 is also given and n2 is also given. It transmits a 10.5 kilowatt power through a belt. So the power transmitted through the belt drive is given. So capital P is also given in terms of kilowatt. We need to convert it into watts. The belt is 115 mm wide, that is 115 mm wide. So width of the belt is given small b, and 12 mm thick. So small t thickness of the belt is given in terms of mm. We have to convert it into meters. Coefficient of friction between the pulley and the belt is 0.25. So mu is also given. The distance between the shaft is 2.75 meters. So x is also given. The smaller pulley is 600 mm in diameters. So diameter of smaller pulley is given, that is 600 mm. Calculate the stress in the belt if it is cross belt drive. So in the difference between the previous question and this question is here. In this question it is clearly mentioned that it is a cross belt drive. So we have to calculate stress for the cross belt drive and also find the length of the belt. So let's solve the question. First we will see what is the given data and what are the steps are required for solution to find stress in the cross belt drive. Also what is required data for the length of the belt. So it is the data given: n1 n2 power capital P, it is 10.5 kilowatt. We had converted into watts. Width of the belt 115 mm, thickness of the belt 12 mm. So from mm we need to convert it into meters. So multiply it with 10 raised to minus 3, we will get 0.115 meters, and multiply it with 10 raised to minus 3, you will get 0.012 meters. Coefficient of friction is mu is 0.25. X distance between the shaft is 2.75, and so the diameter of a smaller shaft is given. It is whether it is D2 or D1, it depends on the RPM. So the diameter of the pulley which is having lesser diameter, it will run at higher speed. So it will run this shaft is running at a higher speed, so its diameter is given. So if it is n2, then definitely it is d2. So d2 is given as 600 mm, that is 0.6 meters. So we can easily calculate what is r2. So r2 will be half of d2, so we will get 0.3 meters. And now what we need to find is maximum stress, sigma max. Stress has been asked, so basically it is expected that you will find maximum stress in the belt drive. So sigma max for cross belt drive we have to find. Also we have to find length of the cross belt. So for open belt drive, what is the data given? What has been asked, that is maximum stress. Stress, we know stress is force per unit area. So if we have to find maximum stress, we need maximum force, and in a belt drive system there are two forces, T1 and T2. T1 is tension on tight side, T2 is tension on the slack side. As the maximum tension is on the tight side, that is T1. So take maximum force as T1 over here, and cross sectional area of the belt, it is B into T. So out of which B and T both are given. Capital T1 is unknown, that is tension on the tight side. So to find tension on the tight side, what is required, or what formulas we have? So directly we cannot find T1 because we don't have any direct formula for T1 in cross belt drive. So to find T1 we need to use two formulas, both of which contains T1 and T2. So by using both the formulas, we will get equation in terms of T1 and T2, and by using simultaneous equation method, we can find T1. So first formula we have is formula of power. Power is equal to T1 minus T2 into V. Power is given. T1 and T2 both are unknown over here, and velocity of the belt is also unknown right now. Then the second formula we can use is T1 upon T2 is equal to e raised to mu theta, of which T1 and T2 both are unknown. So one T1 and T2 you will get from here, and second equation for T1 and T2 you will get from here. So two equations, two unknowns, you can easily solve. But right now you need to find remaining unknowns of these equations. So in the power equation, a small v, that is velocity of the belt, is unknown, and in the limiting tension ratio equation, theta is unknown. So first, the simplest thing, we can find velocity of the belt. Velocity of the belt is given as v is equal to pi dn upon 60. So by once you find velocity of the belt, you can easily find a relation between T1 and T2 in the from the power equation, because power is known. Once you find the velocity, only two unknowns remaining are T1 and T2. So one equation you will easily get from here. The second equation you will get from here is T1 minus T1 upon T2 is equal to e raised to mu theta. So how to find theta? Remember, it is a cross belt drive. So always keep it at the back of your mind which type of belt drive it is. So to find theta for cross belt drive, theta is given as 180 plus 2 alpha over here. Remember the plus sign over here. In case of open belt drive, it is minus sign. In open belt drive, theta is 180 minus 2 alpha. In cross belt drive, it is 180 plus 2 alpha. So you should remember whether you have to use plus or minus based on which type of drive it is. But in this equation again, you will find alpha is also unknown. So we need to find alpha. How to find alpha? Alpha is sine inverse of mod of R1 plus R2 divided by X. So R2 is given, X, that is distance between shaft, is also given, but R1 is unknown over here. And one more thing is the plus positive sign over here. So in case of cross belt drive, alpha is sine inverse of R1 mod of R1 plus R2 divided by X, whereas in case of open belt drive, instead of plus sign there is a minus sign, that is alpha is sine inverse of R1 minus R2 divided by X. So you should remember that in theta equation also you have to use 180 plus 2 alpha, and in alpha equation also you have to use R1 plus R2. So positive sign for cross belt drive and negative sign for open belt drive. So how to find R1? N2 upon N1, both the speed of the driving shaft and driven shaft are given, is equal to d1 upon d2. So d1 upon d2 we can rewrite it as R1 upon R2, because it is twice R1 divided by twice R2. So 2 get cancelled, and you will get N2 upon N1 is equal to R1 upon R2. So R1 is unknown, but R2 is given. N2 upon N1 is also, N2 and N1 both are known. That's why we can easily find R1. So in this way we can easily find by following these steps. That is, first thing, you have to find R1 from here in this equation. Then putting the value of R1 in the equation of alpha, you can find alpha. Once you find alpha, you put this value in the equation of theta, you can find the value of theta. And once you find the value of theta, put in this in the equation of limiting tension ratio, T1 upon T2 is equal to e raised to mu theta. So you will get equation of T1 and T1 in terms of T2 by solving in this way. The second thing, to get the second equation, you need to find the velocity of the belt. Once you find velocity of the belt, put the velocity of the belt in the power equation. You will get other equation in terms of T1 and T2. So solving both equations in terms of T1 and T2, you will get the value of both T1 and T2, and by putting the value of T1 over here in the equation of stress, you can find maximum stress. So in this way you can find maximum stress in the cross belt drive. I mistakenly written over here it open belt, but it is a cross belt. Remember, it is cross belt, not a open belt. Next thing we need to find is length of the cross belt drive. So the formula for length of the cross belt drive is pi r1 plus r2 plus 2x plus r1 plus r2 bracket square divided by x. So again you can observe the difference here in the length of the belt formula. Here it is r1 plus r2 bracket square. In case of open belt drive it is r1 minus r2 bracket square. So you should remember where is the variation between the open belt drive formulas and cross belt drive formulas. So one variation is in the length of the belt over here, other variation in the formula of alpha and formula of theta. So once you keep it in mind, you can easily remember the formulas and you can easily solve the question for both open belt drive and cross belt drive. So first step we have to find alpha. Alpha is sine inverse of mod of r1 plus r2 divided by x. Put all the values. Sine inverse of 0.75 plus 0.3 divided by 2.75. r1 comes to 0.75 by using the formula of n2 upon n1 is equal to r1 upon r2. So r1 value of r1 comes at 0.75 meters. So alpha will get is 22.446. Once you find alpha, we can easily find theta. So theta is 180 plus 2 alpha. Here theta is 180 plus 2 alpha, and this pi by 180, you should remember it because theta is required in terms of radians. So you will get the value of theta from 180 plus 2 alpha in terms of degrees. So to convert it in terms of radians, you have to multiply it with pi by 180. So put all the values, you will get the value of theta. So theta comes at 3.92 radians by putting the value of alpha. Then find the velocity of the belt. Velocity of the belt is given as pi d1 n1 upon 60, or you can write it as pi d2 n2 upon 60. In both the cases you will get the velocity of same. Either you can use d1 n1 or d2 n2, you will get same velocity of the belt. So put all the values, you will get the velocity of the belt as 7.068 meters. Now limiting tension ratio. The equation of limiting tension ratio is T1 upon T2 is equal to e raised to mu theta. So mu is already given and theta we had found. So put both the values. E is equal to 0.25 and mu we had found out to be 3.92. So solve this part only. You will get 2.667. So T1 upon T2 is equal to 2.667. So you will get T1 is equal to 2.667 into T2. Name it as equation number 1. So it will be easier for substitution in the power equation. Now what is the power equation? Power equation is P equal to T1 minus T2 into V. Velocity of the belt we had found and power is given. So put the values of power as 10.5 to 10 raised to 3 and velocity of the belt is 7.068 and T1 we had found out is 2.667 into T2. In this entire equation there is only one unknown, that is T2. So one equation, one unknown, we can easily solve. So T2 will get as 890.63 in newtons. Remember the unit for tension is in newtons. So T2 is 890.63 newtons. Then put it in the equation number 1. You will get T1 as 2376.08 newtons or 2.376 kilonewtons. So T1 we had finally found, but still our question is incomplete because we have to find stress, not tensions. So the formula for maximum stress in the belt is sigma max is equal to T1 upon Bt. We had discussed it earlier that sigma is force per unit area. So maximum stress is maximum force per unit area and maximum force occur in the tight side of the belt, and the maximum force is nothing but maximum tension. So sigma max is T1 upon Bt. So put the values over here. T1 is 2376.08, we had found in the earlier step. B and T, that is width and thickness of the belt, are given, so we can put the cross sectional area over here. Then sigma max, this is maximum stress, comes at 1.72 into 10⁶ Newton per meter square. So maximum stress is 1.72 into 10⁶ Pascal, or we can also rewrite it as 1.72 megapascals. On the last thing remaining is length of the cross belt. So the formula for length of the cross belt is here: pi r1 plus r2 plus 2x plus under bracket r1 plus r2 bracket square divided by x. Put all the values over here. Pi r1 is 0.75, r2 is 0.3, x is 2.75. Put all the values in this equation and you will get the answer of length of the cross belt is 9.19 meters. Remember, for all the same data, that is distance between the shaft and r1 and r2, even though it is same in open belt drive and cross belt drive, but still you will require the length of the belt in cross belt drive is more as compared to the length of the belt in open belt drive. So you can compare from the question number 1 with the question number 2. You will find that length of the cross belt drive is higher as compared to length of open belt drive. Thank you dear all. We'll meet again in the next session. Thank you.